I would like to thank you for joining this session. So today I'm going to speak about creating our first Solidity smart contract with Node.js and Hardhat. So let's begin by having a short presentation about what is going to happen in this video. And first, let's talk about the tech stack which we are using. So I'll be using the Node.js 20.13, which, as you may know, is one of the most renowned and used web application development framework. And on top of it, we are going to use Hardhat. Hardhat is already available as an NPM package, and it's a very versatile and useful tool for creating and testing and also deploying Ethereum smart contracts. So Hardhat is a tool or library that I used already in one of my personal projects, and yeah, it's working pretty well, and I also used it in conjunction with other libraries. But for now we might stick only to the Hardhat, and let's see if the need arises to use other libraries as well. So what we are planning to achieve. I want first to have a correct compilation of the smart contract in Solidity and also of any other code in JavaScript from the Node.js project. I would like to be able this smart contract to be deployable to at least test the blockchain on the local machine. And after we deploy it, I would like to have the possibility to call the contract from JavaScript. Every code that I will produce will be also published to GitHub, and it will be, last but not least, a possibility to learn something new. A few things to consider. So everything that I will talk about in this video has no preparation in advance. So I do have some code which is already in one of my personal projects, and it's working quite fine. The code is pretty complex, but I may get some inspiration from there as well. The license of the produced code will be a MIT license. You can take it. It will be also in GitLab. We can use it, and also if you can distribute it or whatever, you are free to do so. And personally, I like to learn and adapt on the spot. So there are always, when it comes to development, a lot of changes that will come along the way, and I'm going to use various tools and resources to overcome these challenges, to learn something new. And this is the fun of being a developer. I'm a passionate developer, and I like to show you how I work in my own environment. And as of now, I don't have any code, just an NPM, a bare NPM package application, which doesn't have much into it. So we are going to start practically from scratch, and we see where it goes. So yeah, let's go on with it. Okay, so let's start by first checking the Hardhat package on the npmjs.com. So we can see a couple of information about the package and how to install it, and how to use it, and things like that. In this folder, I've already initialized the new npm project. So if I hit ls, I do have a package JSON and a readme file, which is already connected to the Git repository that I've shown to you earlier. So let's see, we have the package JSON, we have a sample one, and what we can do next is to go and check the Hardhat documentation. So we are going to use npm for this one, and I'm going to copy and paste this npm command right here, and it will actually add Hardhat as a development dependency. Why development dependency is because Hardhat is practically creating and generating some files only in the development stage, and this will be then used by the application to call the smart contract and do all kinds of stuff with it. Let's see. So we have it installed. If we check the package JSON, it should be, yeah, dev dependencies. As you see, we don't have yet any other dependencies, but we will add them along the way. Let's practically initialize Hardhat because right now it's installed. Let's see. So personally, I would like to have JavaScript or TypeScript. I will go with JavaScript simply because it's an easier setup. You need no TS config file. Yes, this is the root that I'm having. Yes. Git ignore. I think I already have one git ignore. Let me check. ls-a. I do. Yes. So I don't want any git ignore file. Do you want to install the sample pro with npm? Yes. Okay, so right now it should add the dependencies of the Hardhat, and let's wait for the process to finish. Might take a while. Let's see. Then we have let's go to the official guide. Let's accept all anyway, doesn't matter. And there is also Hardhat. Yeah, I think we will use Visual Studio Code. I also have WebStorm, but many of you folks may not have WebStorm since it's a paid product. Yeah, so it says this talks about installation and things like that. Hardhat, and yeah, and then we can run tasks, and we also have a smart contract. Perhaps we will use a smart contract which is a bit easier than this one, and yeah, and then we will use so this is what's that? It is a test. Okay, this is practically a test. Yeah, and this is also deployment, so we will also reach the deployment part. Deploy your small ignition. Okay, can deploy ignition deploy. Okay, I think they changed some commands because for my personal project I don't remember this ignition to be okay there. Yeah, I remember also this command. Okay, there is quite some stuff. Okay, we have the project creation. So if we hit ls, we have ignition, contracts, and yeah, npm e. Okay, we have everything there. Now let's find our open folder. Yes, I trust myself. Cool. So Hardhat, what it generated? It generated a contract and also generated that lock contract. Okay, which is cool. Ignition modules. This is the code that actually builds the whole stuff, and the test. So this is how we test a smart contract. Yeah, so yeah, let's this is the configuration and all the stuff. So it kind of created some solid let's say backbone or foundation for our project. Cool. Let's add a new Solidity contract right now, and have something which is really easy. Let's have first no something which creates I don't know, computations, that's all. So a contract has a computation that's all extension. We will copy from this lock contract. We are copying the license identifier. I want to have a MIT license for you to use. I don't think we will need console log. Okay, and let's actually start and define the contract. So contract, we will say computations. In the constructor, I think we will just have an easy constructor without any parameters. Okay, let's create the constructor. Yeah, I think it will be staying empty, and let's have a function. So I will define a function which will be public, and let's have a simple sum function, right? And we will have integer num1, integer num2. Okay, let's see. Now we should define what is in the body of the function. So we will practically return a value that is going to be the sum of the two numbers. So this function, for instance, as you will see in the sample, doesn't have any return type. Practically, if I remember correctly, we will need to specify public integer. No. I don't remember exactly how to define the return type. No, integer. Let's see, return num1 plus num2. Now what will it say? Return, I think republic, and then you will say returns integer. Okay. Yeah, so this is how you specify the return time. So practically in this case, we are returning only one integer. We can also return multiple values out of a function in Solidity. Now we have a small warning saying here that we can adjust the mutability to pure. A pure function means that it doesn't change any runtime variables of the smart contracts, right? So if we say public and then pure, we should remove this kind of warning. And yeah, in this case, let's start small. Now with this ignition thing, I suppose build module blah blah blah. What's in okay. So let's also copy this and have it name computations. Yeah, so what happens in this file? We are having the computations, which is going to require some module from the build module, which is coming from the Hardhat. And in this case, we are practically specifying how this smart contract will be deployed. Since in our computations the constructor is empty, we don't need to do much, right? So practically we don't need the constants. We will say build module, and then we'll say computations module. Let's replace this value, computations module. We don't need these parameters as well, so let's also computations m.contract, it will be called computations. Let's copy this value, and it will not so these are the build, not the build, the constructor parameters, which in our case we don't need, because we don't have any constructor in the value locked amount. Okay, unlock time, locked amount. I don't know what is this value locked amount, which is unlock time, locked amount. I'm just curious. Interesting, we will see. I don't know what is this locked amount. m.parameter, it's interesting. So in the contract, I think it's the I think it's the initial value that we will need to put, but no, this is not for us, so let's keep it simple. Okay, and we will return the computations thing. Good. Now for the testing, let's make it sure that we are able to, let's make sure that we are able to compile the contract. So in this case, let's open a new terminal, right? And if we go to the Hardhat page, we will need to find the command to compile our contract. So let's see if this command works. So let's try to run it. We can either run it here, or we can run it in the Visual Studio Code. Oh. Nothing to compile. So we can see that if we go to artifacts, computations, we see our it generated some ABI, it's called. So it's application binary interface. So practically this is some sort of a header which tells other callees of this contract to how to call it, how can you, what are the function it exposes, and how to use the contract practically with the types of the data and the variables and state mutabilities and all kinds of stuff. And com debug, it's, I think, practically some debug info. I don't think we will use that. And this is good news. So right from the start, from the first try, we are able to compile the Hardhat, the new computations contract, which is really, really cool. Now, if we go to the test, we see in our samples, we have lots of tests for the lock contract, which Hardhat previously generated. We will also use this the same format with the Chai framework in order to test our smart contract, and then we will see how we can, let's say, deploy to our test blockchain and call it directly from there. So let's do this. I will create a new computations.js file, and I'm going to just like in the lock.js, I'm going to include all of this, and I'm going to define a fixture which will comprise of all our test cases. Okay, we have described what we know. It's called computations. It's called computation, just like so. And deploy one ear lock fixture. Okay, so in this case we are having a function which will take care of the deployment in the test blockchain, so to say. So let's copy this one and we will say deploy computations. Okay, we will not need these parameters for now. We will stick to something really easy. We are going to leave this code. Contracts are deployed using the first signer account by default. Yeah, that's not a problem. So we will use constant, replace the computations, and we will call into the get contract factory. Let's see if the autocomplete works. Maybe not so much, because it should be available computations. Okay, let's computations factory. I suppose, yeah, I'm pretty surprised that there's no code completion. So practically in the get contract factory, you should be able to specify only two values, so computations or the lock. Anyway, let's computations deploy. So we are going to deploy this stuff, and then we are going to return the computations for now. I also this owner and the other account. Cool. As async function, let's work also. Oh, sometimes I hate this sort of indentation because it works but it's not working. So I want two spaces. Okay. Now let's see how we will describe our first test. Describe deployment. Yeah, you can say describe like that, and we will say no, not deployment, I don't know, sums. So we will describe let's say sums. So let's add a new test. So it should let's do something. It should return the sum of two numbers. Load fixture. Deploy computation. Let's see. So we have the computations. Okay, and let's do some math. So const sum1 equals await. Yeah, we need to use await since you are in asynchronous, and we have no code completion, which kind of sucks. Why? I don't like this one. Perhaps we need to use the TypeScript part, but who knows? So computations dot, what was our function name? So if we go and check it out, we have the function which is called inputs name sum. Sum 1 and 2. And let's say expect, we expect the sum 1 to equal 3. Now let's see if we get some compilation going on. Yeah, and we can go and see what is the command for testing. If we use npx hardhat head test, it should return the sum of two numbers. Yeah, so I got it right straight from the beginning. So we have the computations right. So let's do another thing. Let's see sum2. let's say -1 and 2. -1 and 2. Expect some 2 to equal, this should be equal to 1, I suppose. Let's check it out. Yeah, it's okay. Seems to be quite fine. Let's see what other scenario can we invent. It should return the sum of two negative numbers. Let's have just one sum in this case. So -1 minus 2 should be it should be -3, but let's hit -4, so just in case we have to test if the test crashes in if we have a wrong value. Yeah, so if we have one failed test, we should get a message like that, so we can see we have an assertion error. So we have -3 and it should be -4, so it's not the right value. So in this case we are going to fix it by hitting -3 and running. Let's run the test again. So right now we are having a pass, which is really nice. Okay, now it's time to see about our objectives. So what have we achieved so far? So we spoke about the correct compilation of the sample solidity contract. I think we are on the right track with this one. Deploy to a test blockchain. Okay, this one we are going to deploy also on a local machine with an npx hardhat node command, and we will also see how to call this contract from the JavaScript code. Practically, we called it only from a test, a unit test, but we also want to see how to call it from like a separate runtime JavaScript file. Then, yeah, the publishing sample to the GitHub, this is also on the list. And yeah, learning something new. I think we already learned something already, and we will continue to do so. Good. So let's try to to deploy this to Hardhat internal blockchain. Hardhat provides a command for doing this one. So there is this ignition deploy blah blah blah, but we are going to first run the hardhat node command. Running the hardhat node command ensures we are having some sort of a simulation of a blockchain right on our machine. So if I'm going to this command prompt and I'm going to run the hardhat node, yeah, I can see that it has been started correctly. And now let's try to do a deployment. So if I say hardhat ignition deploy ignition modules, then let's go to the Visual Studio Code command prompt and let's see what happens. So I don't want to deploy the lock.js file, I want to deploy the computations contract. So I'm going to replace this one with the computations, and let's see, npx deployed address. Oh, cool. So we can see some output after we run this command, and we see a successfully deployed, and it deployed this contract to this address. If we see, we don't have any output here, no output, but we have this address which we are going to safely keep into our so deployed to address. Yeah, so this is the address that it has been deployed to. Let's see how we can create some sort of a script, right, to run this contract and directly from this address. We want to interact with this contract. Right now in our package, in our project, we don't have any, let's say, application file. No, I don't want. I wanted to create one. I don't want here. Anyway, I'm going to say touch app.js, and we are going to open this one. So practically we are going to use the let's say the code from the test part in order to get computation, get signers, get contract factory. Practically, let's do something like that. So in our app.js, ethers get contract factory, but we are going to use no, where is the ethers? Or perhaps it's a global import, or I don't know. Let's see, computations. Let's see if this one works fine. Console.log computations. Let's see if I say node app. Problem is that I don't think it will work, because we have also await and all kinds of stuff. So practically we are going to need to define some function which is going to be async function execute, and we need to put everything in there. Async. Oh, this is the goddamn spaces thing. I hate it. Okay. And I'm going to say execute dot then. Okay, just to execute it. Let's see, node app ethers is not defined. Yeah, so practically what happens, also if I remember correctly from the other project, so Hardhat kind of wraps around the Node.js calls. So if I'm going to call node app.js, it will not it will for sure not work correctly. Let's see, npx hardhat -- help run a user defined after compiling the project. I think this is the command we need to run. So run and app.js. Oh, yeah, so now it recognizes our ethers library, and we practically have access to the contract factory for the computations contract. So that's why we can correctly see this output right here. Now I do not know exactly, and this is something that I will need to check. How can I connect the contract with a certain address which is on the local host? So practically, if we get contract factory, it will just get the factory, but we don't want to deploy. So as far as I can see in the contract factory, we have the deployment part, which is okay, but I don't want to deploy because we already deployed it on the local in this right here in this node, blockchain node. So I'm going to do some a bit of research. So I want to say ethers. Let's go on the Google this time. So ethers contract at address. How to get deployed contract address? Not necessarily this one. Get contract factory. My contract that get address. Contract can also go, but not this one. This is not helpful. How to get a contract ethers set? Let's say like that. Set contract address. No, not get, set I want. Sometimes on Google I want too many things, I mean things that it doesn't really know. No mode, network contracts. Connecting to existing contracts, yeah, something like that. Get default provider, ethers, contract address, ABI provider. Yeah, whatever. We can, I think we can try to use this code somehow. Let's see. So let I don't want let. So provider, we are going to use const because this value will not change. Contract address. Contract address should be the ones that we previously got from the output, which we will save right here. We are going to connect the contract using a provider, right? So we will say const computations contract. It will be new ethers contract address, which is correct, ABI, which we will need to get somehow, and I suppose we will be able to get it from the, how it's called, the contract factory, but I'm not sure. Bytecode ABI, this is the bytecode, not the ABI. ABI should be, let's go back to the documentation. So contract, yeah, this is where they define the ABI manually, but we don't want to do so. And let's see, prototype interface, blah 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 blah. But it should be somewhere. ABI, application binary interface. Something is strange, but we will see. So ABI, have contract, AB, computations, interface type constant, inputs, no. But maybe, how come that computation, there's no ABI? I'm kind of surprised. Let's see. ABI is not defined. Yeah, it's not defined. Let's comment this one for now. And we will, yeah, it's undefined. There should be a way. Let's see. Not a text. Can get ABI. There was a way, but ABI is automatically tra-la-la-la-la-la, artifacts. Yeah, but there should be just a simple way to call it programmatically. That's a bit strange. Interesting. We can also use, I mean, require to get the ABI programmatically, but I don't know if it's let's see. So computations ABI equals require and we go to the contracts computation.json. I'm not sure if it will work this way. Let's see. Have no idea if it will work. Computations. So we need another discount. That's all. Anyway, let's see if it works. I'm not sure if it will work just fine. No, you didn't find it. No, it's in artifacts. Okay. Let's see. Oh, come on, you're annoying me. Sorry. Yeah, so this is the file. Why does it say it's not found? Any difference? Cannot find module. Yeah, perhaps we can use I have another idea. Just use our old new friend, because as a developer you are able to leverage any tool that you want. So let's ask this this guy, this wise guy. So I want to ask him to use load a JSON file in NodeJS. But it doesn't work. FS module. Okay, let's use this FS module. I don't know if this hassle is really necessary. To me it's also a bit strange. Why it doesn't find it? I don't have any idea. Or no, I think no. Perhaps let me try one more thing. Oh yeah, now it worked. Okay. So we didn't need any kind of hassle with reading the file. So it was practically so if I'm going to use like that without any relative path, it will look for it in node modules. But if I'm using with /, it will practically call from search it from the current directory. So that makes pretty much sense. Okay, computation ABI. Let's computations contract. Let's first see if this thing works. Oh, ABI is not iterable. Why is that? Oh, just a second. Computation ABI. Something is computations ABI.ABI should be this one. Yeah, let's see. Okay, now we have no longer any error. So let's console log our computations contract. If I'm curious to see if it's initialized properly. Yeah, we have the target interface and the ABI. Cool. Now let's do a sum. Let's do await computations contract that sum 19 blah 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 32. Let's see if it works. Fingers crossed. And error. Could not decode the result data value. Oh, this is bad. This is bad. Computations. Okay, this is bad. I don't think we are on the right track. Let's see. Providers deploying. No. Deploy hello world. No. contract provider or signer, yeah. Something is strange. Computations contract. Let's see if sum2 works. What's the outcome of this? Is not a function. Okay. So this one is going to work, but it cannot decode the data. Yeah, strange, because it should be working just fine. Yeah, let's search for this error. Was getting in h is equivalent to no. I don't know exactly what he did. Get smart contract signer. No. Let me have another look on this one. It's very strange because wanted to have a and how it is in the test. Computation, but I don't want the deploy. Okay, so contract factory, but this one, okay, create instance. Attached. Okay, attached. I think this is the right one, so that I don't waste my time. Sometimes it's also important to stick with to the documentations and not try to fantasize about all kinds of and overcomplicate yourself with all kinds of things. So practically I think we need to computation. So computation equals computations that attach, and we will attach to contract address, which has been defined there. Now let's see. No, it's the same error. Wow. So I didn't do anything wrong in the previous case. So this is how how it goes, right? It's not maybe it's not something from my side that I did wrong, or maybe it doesn't call into this correctly. This is how I'm thinking, because I need to specify but it should be already specified. So contract factory deploy. Interesting. Yeah, deploy transaction. Signer, no. Okay. Yeah, so I did a couple of research in between, and I think I found out a couple of problems. So first of all, Hardhat is reliant on this ethers library, which ethers, if you go to the just by the documents, it's pointing to the I don't know, previously it was the version 5, I don't know why. And actually we are using version 6. And what happens right now, I'm using this custom provider, so practically I'm trying to tell to the contract factory to connect to our blockchain we have running in localhost at this 8545 address, which we can see it right in this place, right? 8545. And what happens when I forced it to go over this local host, on that address I realized that we don't have the contract deployed since I got this warning, right? So that's why we get this sort of ambiguous, could not decode result data instead. And right now what I want to do is to make sure that we are doing the deployment on our local host. So let's see how we can do that, because I think if from this ignition thing we can change the deployment let's say blockchain, deploy a module to the specified network. But how can I specify the network? Because I want the network to be on the local host. And I remember there was a parameter which I don't know exactly, minus network, and I want to say localhost. Okay, deployed address, but I need to see something. Oh, you see I have some stuff. Contract address, okay. Method not supported, I don't know what's that, but I think it's the same address. All right, if I deploy again, I'm just curious if it changes the address. It doesn't. Strange anyway. Okay, let's try to run the application again. Yeah, now it works. And we see we have 90 plus 32 is 122, right? That's correct. I don't know why it's with n at the end. I think this is because it's a long number or something like that. I'm going to ask GPT. If GPT is not able to answer this one, why in that log is written n. Let's see how smart it is. N indicates is a big integer. Okay. But I don't want to have it with n in the end. How can I remove the n at the end when logging to console? Let's see. Convert to string. Okay. String or number. Okay. Let's see with number. So if we say something, oh no, let's do something nice. So let's have the numbers. Const num1 equals 90, const num2 equals 32. Okay, and then we are going to use the interpolated string when we will say the sum of num1, number 1, and number 2 is, and we are going to use the await statement and the whole schmear right in this place, and let's run it again. Cool. So right now we can see the result right here. So we can also see that we have actually called the computation method, right? We have called it, we can see the contract call right in the console. And I think that's why we got the error, because practically it didn't go to this blockchain, right? It goes to somewhere else. Let's actually do another test. Let's see if we can let's reuse the same provider. I think we might get the same error, yeah? And we see no call in here. So this is because it goes to some runtime blockchain which doesn't have the contract deployed, and that's why we get the error. But by using this provider, custom provider, we are going to be just fine. And yeah, let's do some perhaps we can do some cleanup as well. Attach, we don't need this one. I want to remove these ones. Computations, this one is not needed anymore. Yeah, practically if you use TypeScript you also get much better code completion, but for now let's stick to to the JavaScript part. And yeah, I think we kind of approach all the problems, and I'm also going to publish the sample code to GitHub, sorry. And yeah, hope you learned something interesting, and I'm planning to add more videos on development purposes and around development tasks, because I think they are pretty interesting, and it's definitely something new to learn, and it's also challenging, as you can see. Yeah, so thank you for watching this far, and enjoy and all the best. Cheers. On this note, thank you for watching. Hope you enjoyed this video, and if you like and want to receive more videos like this, please like and subscribe to our channel. And all the best from Afieter. Cheers.